4.5. Solving problems using quadratic functions. The first example we're going to look at is from page 236 and example number 2. So here comes the problem. Mr. McIntosh has 90 apple trees. He earns an annual revenue of $120 per tree. If he plants more trees, they have less room to grow, resulting in fewer apples per tree. As a result, the annual revenue per tree is reduced by $1 for each additional tree. Regardless of the number of trees planted, the cost of maintaining each tree is $8, where X is the number of additional trees planted. How many trees must Mr. McIntosh plant to maximize his profit? All right, so what we have to understand here is how to get the problem, how to get the equation. Notice that in this problem, there is no equation given. This would imply that this is an inquiry or thinking type problem, which will involve developing the equation first before we can solve. So, let's look at revenue. What is revenue? Revenue is price times the number of items that we sell. So price times the number. In this case, we have a certain price that we have, which is $120 per tree. And what happens is we also have a number of trees that we sell. So at $120, we sell 90 trees. But what happens is that we end up losing $1 for every additional tree that is planted. So 90 plus one extra tree will be $120 minus $1 for every tree that's extra that's planted. So that's how we get this problem. So again, let's understand this. As we increase one tree, we make $1 less, and that's where we have these values here. Now, there's also a cost. So revenue is money coming in. Cost is money going out. How much does it cost to maintain a tree? Well, it costs $8 times however many trees there are. In this case, there are 90 plus X trees. So we have a cost, we have a revenue, and now we can determine profit. Because the question is asking how many trees must Mr. McIntosh plant to maximize profit? Well, what we're looking at here again is profit is revenue minus the cost. So we're now going to look at the equation with revenue minus the cost. So again, the price times the number of trees is the revenue, and the cost is how much it costs per tree that we're actually making. So let's look at the equation. We will have an equation as follows. Okay, we will have profit is equal to revenue minus cost. This is your revenue, and then we're going to subtract your cost, and that will equal your profit. So how are we going to solve this? Well, we need to expand this all out. So we expand it out, and we get 10,800 plus 120x minus 90x minus x squared minus 720 minus 8x. Collect like terms. So we have minus x squared plus 22x plus 10,080. Next step we want is maximize the profit. What does maximize mean? Yes, that's right, folks. We're going to complete the square. So let's complete the square and find the vertex. So what we need to do here is remove the jacket. And that's what we did here. Remove the jacket. And then what we have to do next is invite twins. Now remember, this is a lot of writing, so we're going to move a little backwards a bit. So we have minus 1 x squared minus 22x. We have a positive twin that stays inside, and we can immediately just push the negative twin on the outside. Again, too much work here. So here we go. So I took the positive twin, which is negative 22 divided by 2 and squared, positive 121, and minus 121 is on the outside, multiplied by the jacket, which is negative 1. And then we have plus 10,080. And let's go through the rest of this. Where do we get the next? So here are the twins, folks. We keep the positive inside, we kick the negative 1 out, and we multiply by the jacket. Complete the square for this, so factor it, we get x minus 11 all squared, and then we simplify these values here to give us 10,201. So our vertex is 11 and 10,201. What does that mean? What does this vertex imply? Well, the vertex being 11 and 10,201 means that we need x is 11. 10,201 is the profit. So we need to plant x number more trees. So in this case, it's 11 more trees so that we can have a full profit of $10,201. So that's what the vertex tells us. All right, folks, moving on to the next example. We have this case. This example is from page 238, example number 4. A bus company usually charges $2 per ticket, but wants to raise the price by 10 cents per ticket. The revenue that could be generated is modeled by the function, where x is the number of 10-cent increases and the revenue Rx is in dollars. What should the price of the tickets be if the company wants to earn $21,000? So from page 238, example 4, it's not asking for a maximum or minimum, so it's not asking for a vertex. What it's asking is, what should the price be if you need to reach a certain value? Well, that value is 21,000. That has to equal the equation. We have the equation in the problem. There it is, folks. And we set them equal to each other. And what we do now is expand and collect like terms. So we move things. In this case, what we did is we actually solved it. You can expand it, collect like terms, and then use quadratic formula. Or, because the formula is literally have x right here, and we need to get x by itself, what we can do is move things over. For example, plus 25,000 moves over, you get negative 4,000. Then we divide both sides by negative 40, and that gives us x minus 5 squared on the right side and 100 on the left side. Next thing we're going to do is take the square root of both sides, and that gives us plus or minus 10 is equal to x minus 5. And that means that we have a final x of 5 plus or minus 10. 5 plus 10 or 5 minus 10. So we need to find the values. That means x is equal to, if we add 15, if we subtract, x equals negative 5. So what should the price be? Well, if we're looking at in terms of dollars, and x is the number of 10-cent increases, we either take $2 and decrease by 5 times 10 cents, or we take $2 and increase by 15 times 10 cents. So let's look at the numbers. X equals 15 means the price is going to be 15 10-cent increases. So the price is going to be $3.50. If we have x equals negative 5, that means we have negative 5 10-cent increases. That means our price is actually going to go down 5 10-cent increases, which is 50 cents, and the price is going to be $1.50. Both of these values will indicate that their revenue will reach a minimum of the value of $21,000, which is what was originally asked for. Okay, well, that's the end of this video, folks. So again, let's just go recap. We need to reach a minimum of $21,000. Those values that we found in this question, $3.50 and $1.50, means that we will reach our value of $21,000. Okay, folks, that's the end of the video. Have a numerical day.